Hello everyone, let's take a look at our next problem. A finite set S of distinct real numbers has the following properties. The mean of S union 1 is 13 less than the mean of S, and the mean of S union 2001 is 27 more than the mean of S. Find the mean of S. Okay, so I think this is just going to be a question of setting up a few equations which represent exactly these properties. So the first thing I'm going to do is I'm going to let n be the number of elements in S. We're told it's a finite set of real numbers. And I'll also declare a variable which represents the sum of all the elements in S. So then the mean is going to be, well, let me write this down. So n is the number of elements in S, and I will let, I would love to let S be the sum of things in S, but let's say P is equal to the sum of little s, where little s is in capital S. Okay, so P is the sum of all the elements in S. Then the mean of S is equal to P over N. Okay. And the two properties we have here, the first is that the mean of S union 1 is 13 less than the mean of S. So this tells us immediately that the number 1 is not an element of S already, because when we take S union 1, we get something different. Okay, so let's write down exactly what that means. So P plus 1, that's the sum of all the elements in S. This is the sum of all the elements in S union 1, right there. And when we divide, this set now has n plus 1 elements. So this is equal to 13 less than the mean of S. The mean of S is P over N. So there we go. And we have something similar. P plus 2001 divided by n plus 1 is equal to P over N plus 27, because the mean of S union 2001 is 27 more than the mean of S. This here is the sum of all elements in S union 2001, and we have now one more element. And what we need to find here is the mean of S. So we need to compute what P over N is. Now, P does not have any restrictions. We're just told that it's a set of distinct real numbers. N, of course, has to be a positive integer. So how could we figure out what this system of equations, how do we get P over N from this? And the first thing I'm thinking is perhaps to just add the two equations together and just see what happens. I wonder if we'll be able to solve for P and N individually. I mean, it's two equations and two unknowns, right? So in theory, we could do that. I'm going to start by adding the two equations together. It'll cancel these constants in the right hand, or it won't cancel the constants. No. Will it be useful to solve for N in terms of P or vice versa? I don't know. I'm just going to play around with some algebra here. I don't really have a well thought out plan for what direction I'm going to take to solve these equations, but I'm just going to mess around and hope something nice happens. Okay, so this did end up being a little bit more straightforward than I thought. I'm not quite done yet, but I have solved for N. I should have seen this immediately from the equations. If I could take a difference of these two equations, then this P over N ratio cancels on the right-hand side, and I get something pretty simple on the left-hand side as well. It just turns into 2,000 divided by n plus 1. And then we can solve for n, we get 49. So I'm going to substitute this back into one of these equations and solve for p, and then compute p over n. Okay, after some algebra, some arithmetic, I didn't actually end up solving for p. I was able to isolate sort of p divided by 49 on its own. And I end up with 651. So I'm very confident in my approach to this, the way I set the problem up, specifically writing down these two equations and then just needing to solve for the ratio p over n. Basically, I ended up solving more or less for n and p individually. It's possible that I made some errors with the arithmetic, but I did end up with a whole number here, and this being the AIME contest, the answer does have to be a positive integer. So, yeah, I'm fairly confident in this. If I find an error, or if I have anything more to say about this question, I'll put it in the description. Otherwise, thanks for watching.